Hi all, my name is Jayasri, working as Assistant Professor in Department of CSE AIML, MLR IT. Today my topic is about taxonomies and ontologies in cognitive computing. What is a taxonomy? Okay, in previous session we have seen about taxonomy and ontologies in knowledge representation. So I would like to show you the taxonomy in different areas of cognitive computing. Now we have seen taxonomy in NLP used in businesses. We have seen taxonomy and ontologies in used in knowledge representation. Now in this session we'll be talking about taxonomies and ontologies in cognitive computing. Okay. So before going into how these taxonomies and ontologies are used in cognitive computing, again let us just have a brief about taxonomy and ontology. Okay. So here it's a hierarchical classification system. Taxonomy is a hierarchical classification system that organizes knowledge into structured category. Hierarchical classification system is something which is already inbuilt. I have some model which is already inbuilt, and from this I'll have a child nodes where I can inherit the habits of the inbuilt model. That's called a hierarchy. So this hierarchical classification system is that it classifies the model into different levels and also organizes them based on the category. Okay. So here you can represent the data in a parent-child structure. Now this can act as parent and these are child nodes. Now here if you are talking about the diagram here, we know that the vocabulary shows the ontology structure. Okay. So here in case if you are taking a vocabulary which is summed up with a particular structure, you get a taxonomy. Okay. And this taxonomy, if you are summing up with relations, limitations and rules, you get ontology. Now, what is this structure, relation, limitations and rules? These are nothing but analytical. It's an analytical relationship among terms. Okay, it's an analytical relationships among terms. Now, these analytical relationships shows what it forms, whether it forms a taxonomy or it forms an ontology based on the vocabulary. Say you are pairing up the structure with vocabulary, you get a taxonomy. Or you are pairing up relations, limitations and rules with taxonomy, you get ontology. Clear? Right. Now, hierarchical organization. Hierarchical organization is groups related to concepts. It have different groups which are related to concepts. Like I have the parent AI. Now it is having a different group. AI is directing to ML, it is directing to DL and so on. Right? Next, I have classification and categorization. Classification and categorization is used to help in searching the information, retrieving the information and AI driven recommendations. Like I have given an example in the previous slide of a person in case if he is browsing an e-commerce website or shopping shoes or a refrigerator. Okay. refrigerator, then your system gives a recommendation that you have some more models related to different companies, right? So likewise, if you are watching movies or you are watching a web series in Netflix or any other social media website, depending on the interest of yours, like you are watching fiction or you are watching horror, okay, it gives a recommendations of you can either watch this movie or you can watch another movie related to your interest. So you try to you watch, your system is recommending you and you can have a preference to watch that recommendation. Okay. Strict relationships. What is the strict relationships? This is one-to-many relationships. One-to-many relationships is an apple is a type of fruit. There are n number of fruits. Okay. Apple is one of them. One of them. So strict relationships is something that we have n number of fruits. We have n number of vegetables, but vitamins, minerals, iron, so on will fall under only few categories or few items. That is strict relationships. It is restricted only to a particular content, a particular area. Next, medical diagnosis system. Medical diagnosis system like medical taxonomy. Now here, if you are talking about a disease related to respiratory is called asthma. Disease related to neurological disorder is called Alzheimer's. How does it help? Now this person called Watson, he helps to classify the patient. How? Based on the symptom. How? Based on the symptom. Now this symptom is having a medical taxonomies and it suggests the possible conditions. If he is having a symptom related to Alzheimer's, then you need to take this prescription. You need to follow this condition to minimize it or to at least time being take him to the hospital. Right? It helps in this form. Next, what are the limitations of taxonomies? Like it lacks of complexity. It cannot represent multidimensional relationships. It cannot represent multidimensional relationships. What are the limited reasoning for it? It cannot infer new knowledge beyond hierarchical classifications. It cannot infer new knowledge. You cannot take any new knowledge beyond hierarchical. Now say I have A to C in my parent node and I give 4. Okay. Now this is something that it is violating the limit. The limitation is something that it has to follow the hierarchy classification. If I give X, yes, it identifies a relation because it is already known for it. Okay, if something beyond or out of the range if you give, it will not be able to identify that particular data. Next, this is all about taxonomies. What is ontology? Ontology is a structured knowledge model. Ontology is a structured knowledge model that defines concepts, it defines relationships and rules within a domain, and also enables AI to understand, infer and reason with the knowledge. Whatever knowledge you have, it tries to understand with the help of AI. It also infers that what the information it is having is correct, and it gives the reasoning for the knowledge. That what is the understanding of the knowledge, it gives reason that this might be the reason for it. Okay, this might be the condition for the ontology. Okay, now basically, what are the features of ontology? When you talk about the entities and concepts, it defines objects in a domain. It defines objects in a domain. What is a domain? Patient, doctor, disease. When you're talking about the other feature called relationships and properties, it specifies how concepts are connected. It specifies how concepts are connected. Now, a doctor treats a patient. Yes, a psychologist treats a patient. Okay. Now, will the vegetable seller treat a patient? No, right? So, the relationship and property should be relevant so that the relation is incompatibility with the entity. Logical inference. Logical inference is it can derive new insights. It can derive new insights like if fever is a symptom, if fever is a symptom of a flu and John has fever, he may have flu. That's a logical inference. Okay. Next. Now, this also ontology is introduced in healthcare like disease symptom medication. Relationship, fever is a symptom of malaria. Paracetamol is treats the fever. Malaria is caused by mosquito bite. Now, it is clear. Fever, symptom of malaria. Paracetamol treats the fever and malaria is the cause of mosquito bite. Right? How does it help? It helps AI in analyzing the patient's data based on the reports, based on the tests or whatever so-called report he is having based on the data, and it provides the personalized treatment recommendations based on the patient's data, right? Whether what kind of symptom he's having, whether it's a flu, whether it's a normal cold, cough, fever. Okay, so based on that, your AI helps to analyze what kind of comfortability he is having and what is the symptom for the patient. Now let's see the difference between taxonomy and ontology. Ontology versus taxonomy in cognitive system. The structure in taxonomy, it is hierarchical, and in ontology it is network based. The relationship between taxonomy is single parent child, wherein the ontology is a complex one to many, many to many relations. In checking for inference, it is having no logic reasoning, but in ontology, it enables AI reasoning concept. The use cases classifies and searches in taxonomy, but in AI based decision making, ontology plays a major role. Next, applications of taxonomies and ontologies are, we have many applications, out of which we will be discussing only 4 here and few, like Google Knowledge Graph, which is already discussed. This is, it uses ontology based on relationships to improve the search results. This improves the search results. Who? Google Knowledge Graph improves the search results. Healthcare AI. This uses ontologies to diagnose diseases and recommend treatments. Chatbots and virtual assistants. Chatbots and virtual assistants. Here, the ontology enhances natural language understanding like Siri, Alexa, Google Assistant, so on. And another application is about business intelligence, where AI-driven recommendation systems use taxonomies and ontologies to personalize user experiences. Concluding taxonomy and ontologies. Taxonomies classify data hierarchically. Why? To easy search and categorization, where ontology defines relationships and it also enables AI driven reasoning. Now, both these are essential in cognitive computing. Why? To enable AI system and also to understand, analyze, and make intelligent decisions. I hope the session is clear for you, and thank you.